We can take a quick example of applications of functions. Specifically with this one, I want to look at a piecewise function. This function gives us the average daily rate of US hotels from 2016 to 2019. And this is a piecewise function. All right, so we are representing f of t to be our function that's measured in dollars. And t equals 0 is corresponding to 2016. All right, so 2017 would be t equal 1, 2018 would be t equal 2, and 2019 would be t equal 3. And so between the years 2016 to 2018, the daily rate of US hotels can be represented by this quadratic function. But then between 2018 and 2019, the daily rate of hotels fits a different model, like this linear model, negative 5.58t plus 117.85. And we would want to be able to find the average daily rate of US hotels in different years, 2016, 2017, 2018. Okay, so let's take a look at this. So in 2016, what is the average daily rate of US hotels? In other words, we're trying to find the value of that piecewise function that corresponds to the year 2016. And we've said that 2016 corresponds to t equals 0. And I may want to mention that we're using t as our domain, as our input, as opposed to x. In many of the applications of functions, we'll use t because that's our because time is our most common input, is our most common domain. So if we have time, that's usually going to be represented by t as opposed to x. But they mean the same thing. If you're more comfortable with x's, you can replace those t's with x. All right, so 2016 corresponds to t equals 0. And so we need to know which piece of this function we're going to plug t equals 0 into. Well, this is where the restrictions come in. All right, we look to see which piece that this fits. Well, t equals 0 falls into the first restriction, this 0 less than or equal to t less than 2. So we're going to use this first piece to plug t equals 0 into that piece of the function. So this is 0.88 times 0 squared plus 3.21 times 0 plus 96.75. And of course, 0.88 times 0 squared is 0. 3.21 times 0 is 0. So we're left with 96.75, which is the average daily rate of US hotels in 2016. Okay, and so we can do the same thing for 2017. 2017 corresponds to t equal 1. And so which piece are we going to plug 1 into? Well, we look at the restriction. T equal 1 falls into the first restriction again, right? 1 is between 0 and 2, so we'll use that quadratic function. So 0.88 times 1 squared plus 3.21 times 1 plus 96.675. And so that's 0.88 plus 3.21 plus 96.75. Which is $100.84 for the average daily rate of US hotels in 2006 and 2017. All right, and then we will take a look at 2018. This will have t equal 2. We'll need to see where this falls into for the restriction. T equal 2. This is no longer in the first restriction. because the first restriction is between 0 and 2, but not including 2. All right, so for t equal 2, we'll need the second restriction. This is 2 less than or equal to t less than 3. So we will plug t equal 2 into the second piece, since it satisfies that restriction. So that's negative 5.58 times 2 plus 117.85. Negative 11.16 plus 117.85, which is $106.69. That is the average daily rate of U.S. hotels in 2018.